Welcome! In this video, we're diving into database design patterns. These are proven architectural patterns and best practices for designing scalable, maintainable, and efficient database systems. Consider it as a collection of solutions for various database-related problems. Here, store multiple entity types in one table. Let's consider a table named Employees. It has columns like ID, name, email, and importantly, a type column. The type column indicates whether an employee is a manager, a developer, or a designer. Depending on the type, certain columns become relevant. For example, team size is specific to managers, while programming language applies only to developers. This is done using one single table. Class table inheritance pattern means separate tables for each entity type with a shared base. There's a base table called Employees, containing common information like ID, name, and email. Then, there are specific tables like Managers, which have a foreign key employee ID, referencing the Employees table, along with columns specific to managers, such as team size. Active record pattern refers to the objects that wrap database rows with behavior. Consider a Python class called user. It has attributes like name and email, initialized in the __init___ method. The save method inserts or updates a record in the database, and the delete method removes a record. In essence, the object itself is responsible for database interactions. Repository pattern suggests encapsulating data access logic in a separate layer. Let's define a class user repository. The findById method queries the database to find a user by their ID. Similarly, findByEmail retrieves a user by their email. The save method contains the complex logic for saving a user, abstracting the database operations from the rest of the application. Unit of work pattern refers to maintaining a list of objects affected by a business transaction. Consider a class unit of work. It tracks new objects, dirty objects, and removed objects. The commit method processes all these changes within a single database transaction, ensuring atomicity. It inserts new records, updates modified records, and deletes removed records. Data mapper pattern separates in-memory objects from the database. Imagine a class called userMapper. The find method queries the database and then calls mapToObject to transform the row into a user object. The mapToObject method creates a user object from the database row. The insert method handles inserting a user object into the database. Identity map pattern is used to ensure each object is loaded only once per session. Here's a class called IdentityMap. The get method first checks if an object with a given ID exists in its internal dictionary. If not, it loads the object from the database using load_from_database, stores it in the dictionary, and then returns it, ensuring that each object is only loaded once. Lazy loading pattern is used to defer initialization until the value is needed. Let's consider a class user. The constructor initializes the ID, but the orders are set to none. The orders property uses a getter with the @property decorator. When orders is accessed for the first time, it checks if _orders is none. If so, it loads the orders by calling loadOrders and stores them, ensuring orders are only loaded when accessed. So here's a recap of the key patterns we covered. We discussed inheritance patterns like single table and class table approaches. We looked at object relational patterns such as active record, repository, and data mapper. We also explored session management with the unit of work and identity map patterns, and performance optimization using lazy loading strategies. Choose patterns based on your specific requirements and constraints. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.